Hi Year 8s, let's look at chapter 9c, finding the rule using tables. Guys, I want you to have a look at this warm-up. There are two tables here on the left-hand side, table 1 and table 2, and I want you to pause the video and find out, or try and have some time and work out the relationship between the values in the X column and the values in the Y column for both tables. And can you find what the relationship is between the values of X and the values of Y? Pause the video and give yourself some time, 5 minutes, to work out what you think those relationships might be. Okay, guys, let's look at what those answers might look like. So find the relationship between X and Y in these tables. So let's look at these pairs of coordinates we have here. First we have X equals 0. If X equals 0, the value for Y is given to us, it's known. So the value of Y when X equals 0 is 4, okay? So how did we get from 0 to 4? What could we do? We could say, well, we're just going to simply add 4 in this case, right? But does that adding 4 suffice for every single pair of coordinates? Let's have a look. So if X equals 0 and we add 4, Y must equal 4. What if we add 4 to X equals 1? If we add that, we end up with 5. So that does suffice the rule. So we have two pairs of coordinates that the rule works for. Does it work for the next pair of coordinates? 2 plus 4 equals 6. It does work. Does it work for the fourth one? 3 plus 4, well, that definitely equals 7. So it seems like we've got a rule that works for all pairs of coordinates here. The last one is 4 plus 4, yes, and that equals 8. So the rule must be here. Whenever we have Y, we're going to take X and add 4 to it. So that's the value of Y. What about this table here? Did anyone have a go at this one? Let's have a look at the value of X and the value of Y. Here we have one coordinate X is -3, and when X is -3, it's been told that the value of Y is -5. So how do we get from -3 to -5? Well, we minus 2, don't we? Subtract 2. So if we subtract 2 from -3, we end up with getting -5. So does subtracting 2 work for all of these pairs? Let's do -2 minus 2. So we know -2 minus 2 is -4. So that rule does not apply, okay? Because the answer here should be -3. It's not that rule. This rule that we've thought of does not actually work. So it can't be minusing 2. So what's another relationship we can see? Well, here we've got 0 and 1. If X equals 0, then Y equals 1. Can we simply plus 1 to all of these, and will that rule work? Well, if we look at these ones, no, we can say that this rule doesn't work. It doesn't actually work for this one. 1 plus 1 equals 2, not 3. So what is the rule here? Okay, did anyone come up with this rule here? Y equals 2X plus 1. If you did, well done. This is a hard one. So we can say that when Y equals 2 times X plus 1. And let's try and work it out for all of them. So if Y equals, we don't know what Y is going to equal in this case, 2 times -3 plus 1. So let's see what that adds up to. 2 times -3 is -6, plus 1 is -5. Does that check out? Well, it does check out. There we go. We've got -3 and -5. Let's check it out for this one here. Y equals 2X plus 1. Well, if 2X is 2 times -2 in this case, plus 1, do we get -3 over here? 2 times -2 is -4, plus 1 is -3. So it does work, okay? So it looks like our rule is starting to work for all of those. So that's our rule for those, and that's our rule for this one. Let's just do another one in another set of coordinates to make sure our rule works all the way down. Let's check these two coordinates here. If X equals 1 plus 1. What is the value of y? It should be 3. Let's check it out. 2 times 1 is 2 plus 1. Well, there you go, 3. Okay, so this is how we're looking at different relationships between two unknown pronumerals. Okay, so this lesson is all about finding a rule. Just like we found these two rules, there's a key to working out the rules, and it's quite easy. So let's look at the rule for writing linear equations. Okay, and this is our formula. So we have always got the y unknown on the left-hand side of our equal sign, and then we have another expression on the other side, on the right-hand side. So y equals the coefficient of x, so that might be our unknown, okay? It's going to be a variable number. Y equals the coefficient of x plus another number. So it could be plus a positive number or plus a negative number, and that's what we call as a constant term. Our constant term doesn't have a pronumeral attached to it or multiplied by it. All right, so how are we going to find out what the value of the coefficient is and what the value of the constant term is? So there's two rules, and you need to make sure you know these ones or have them written down somewhere that you can find them easily. So we work out the coefficient of x. So the coefficient of x is the increase in y. So whether that's an increase or decrease in y as x increases by 1. Okay, and we work out the constant term. The constant term will be the value of y when x equals 0. Okay, so here we have two examples, and I've got a filled in table here of data coordinates and another one here. So we're going to try and fill in our linear equation rule. Okay, we're going to try and find our coordinate of x and our constant term on the end. All right, let's look at our table here. We've got our x values and we've got our y values, and each one of these is a pair of coordinates that we might plot on a Cartesian plane. So we have 5 pairs of coordinates that we can use to plot on a graph. But we're not going to do that yet. We're going to be looking at how to write the rule. So how do I find the coefficient? So the coefficient is the increase or decrease in y as x increases by 1. So let's look at x up the top first. Is x increasing by 1 each time we go across? Yes, it is. So we have -2 to 1, that's increasing by 1. -1 to 0, that's also increasing by 1. So yes, we can check that part off as x increases by 1. Now let's look at the pattern of y. So here we have -1 to 1. So that's actually not an increase of 1, that's an increase of 2. So that's adding 2 each time. So +1 to +3, well, that's another increase of 2. +3 to +5, that's also increasing by 2. So it looks like we have a pattern occurring here. Whenever x increases by 1, y is increasing by 2. So that's our coefficient. +2 is our coefficient, and we put it down here. Okay, so 2 or just +2, +2 or just 2. And then we have to look for our constant. So what's the meaning of our constant is that the constant will be the value of y when x equals 0. So let's look at our data table here again. When x equals 0, this will be the value of the constant. So let's look at y. What's the value of y when x equals 0? Well, we can see that it is +3. Okay, so this is our rule for this particular data set. Y equals 2x plus 3. Okay, let's look at this one here. Here I've got x, and we can see what the pattern is of the x's. They are also increasing by 1 each time, just like this table here. So what's the pattern of the y's? What's happening here with the y's? Each time we are decreasing. Well, we're decreasing by 1 this time, every single time. Okay, so it's that coefficient when x is increasing by 1. What's the pattern happening to the y's? Well, it's decreasing by 1. So that's going to be our coefficient of x. And when we have our constant, it's going to be the value of y when x equals 0, and the value of that would be -1 in this case. So let's rewrite this slightly so it's a little bit cleaner and easier to read. So here we have y equals -1 times x. Well, that's just -x plus -1. That's just -1. Okay, last one is if we have a table set or a data set that does not have a value of 0 in it. Okay, I'm just going to get rid of all of this. Let's try and work out the rule when the data table doesn't give you a value of x equals 0. Okay, what about if we have x and y? And we have 2, 3, 4, 5, 7, 9, and 11. Okay, this is our data table. We have our known values for x and y, but we're going to try and make up the rule for this data table. So if y equals something times x plus something again, what is the pattern? Is x increasing by 1? Yes, it is. So now we can check to see what the pattern is when y, is it increasing or decreasing? Well, we can see that it's increasing by 2 each time. 7 to 9 is 2. 9 to 11, you're adding 2. So this value here will go here for our coefficient. So it's 2 times x plus or minus whatever the value of y is when x equals 0. But if we look at the table, we can see that there's no x equals 0 up here. So how do we work this out? So I can take any two other coordinates. So I might just take these two simple small numbers here, and I'm going to put them into our formula. So right now I know my formula is y equals 2x plus something. We don't know what that something is. But if I take two of these coordinates, my known coordinates, and I just put them into or substitute them into the formula, I know that y equals 5, and then 2 times x, well, x is 2 plus something, okay? So what does 5 equal 2 times 2? 2 times 2 is 4 plus something equals 5, and so therefore we know that that number must be 1. In this case, it's 1. So now we can bring that number back up here and use that as our constant term, and we're going to rewrite this equation so it's a little bit easier to read. That's going to be y equals 2x plus 1.